So I'm going to do two examples to figure out either the wavelength, the frequency of a standing wave. The first example is problem 20, is out of homework 20.2. It is problem A. So it says the length of a pipe is 1/2 meter. So there's the length. It says it's the second harmonic. So the second harmonic is going to look like this, one complete wave. Fits in the second harmonic. So remember the second harmonic. That tells you information. What information does it tell you? Specifically that there is one wave that fits in the pipe. So if you wanted to figure out the wavelength from this, wavelength is just the length of the pipe divided by the number of waves that fit inside the pipe or the tube. So in this case, it's simply 0.5 meters because the length is 0.5 and the number of waves is 1. So now that we have that, the question is, how do we figure out the frequency? Well, we're going to use the old equation that we've played with for the last few weeks. Frequency is speed divided by wavelength. We're talking about sound waves here, so we know that the speed of sound is 340. That's meters per second. The wavelength we just figured out was 0.5 meters. I can do this in my head basically because I know that dividing by 0.5 or half is the same as multiplying by 2. So if I double the number here, I should get 680, and the meters cancel out to leave per second, which is equivalent to hertz, and that's exactly what we should get if we're trying to get a frequency. Okay, so the next problem is going to be a little bit outside of the box. It's not identical to any of the homework problems. It's not identical to any of the starter question practice problems we've done in class. The purpose of this is to try to develop some problem-solving skills. We're very familiar with the equations that we'll use. We're just using them to solve for something a little bit different. So here's the problem. We hear a 1308 hertz sound coming from a guitar string. If the guitar string is approximately 65 centimeters long, the goal for the problem is to try to figure out what harmonic is actually being played by this guitar string. So basically what we have given is the frequency is 1308 hertz. And we know that the length of the guitar string is 65 centimeters, which is equivalent to 0.65 meters if you divide by 100. Because there's 100 centimeters equivalent to 1 meter. And again, it's trying to ask us what harmonic. We don't know. Is it the first harmonic, the second harmonic, the third harmonic, the fourth? It could be the fifth or the sixth. The point is we don't know. So at this point, I would encourage you to pause the video and think about how we could possibly do this. The first step is think, based on the information that's given, what could we possibly figure out? It may not be the harmonic first. Maybe we could figure out something else about these waves. So I would press pause and think about that before we continue. Okay, so if we continue with this, one of the things that we can figure out is that the wavelength is equal to the length of the guitar divided by the number of waves. remember, the number of waves, that will tell us the harmonic. If there's half a wave, that's the first harmonic. If there's one whole wave, that's the second harmonic. If there's 1.5 waves, that's your third harmonic. 2 waves, that's your fourth harmonic. So if we can figure out how many waves, that'll tell us the information about what harmonic is being set up in the string. Now, that's not too bad. We have the length already. The number of waves is what we're trying to solve for. We don't know what the wavelength is yet. However, there is another equation that we've used in the past to figure out the wavelength. It's the speed divided by the frequency. Now again, we're dealing with sound waves, so we should already know what the speed is. The frequency is given as 1308. That's hertz. So that should give us 0.26, and the units there are meters. Again, the hertz cancels with the per second, leaving us with meters. So we can get a wavelength. So let me clear this out so we can see this equation again. We just calculated the wavelength. So the wavelength we know is 0.26 in meters. The length of the guitar in meters is 0.65. All we have to do is solve for the number of waves. So if we can figure out the number of waves using some algebra, the number of waves should equal 2.5 waves. So we get 2.5 waves. What does that mean? Well, let's look at the picture of the guitar strings on the right. Again, here's the first harmonic with half a wave. Here's the second harmonic with 1 wave. Here's the third harmonic with 1.5 waves. Here's the fourth with 2 waves. Take a look at the pattern. Increases by a half every single time. So if we were going to get 2.5 waves, we would be in the 5th harmonic. So there's our answer. The 2.5 waves, that tells us we're in the 5th harmonic. There's our answer, the 5th harmonic.